Inside a dying star, sound waves travel at one-third the speed of light. That is not a metaphor. That is not an approximation. The pressure waves ripping through a collapsing stellar core move so fast and carry so much energy that they would vaporize you before your ears could even register a single frequency. Let that sit for a second. We think of sound as something gentle. Music, a voice, a thunderclap. But inside a star on the verge of death, sound becomes a force capable of ending everything. And the fact that this is physically possible rewrites what you think you know about matter, energy, and the universe itself. Here is the setup. A massive star, say, 20 times the mass of our Sun, burns for about 10 million years. It is fusing hydrogen into helium, helium into carbon, carbon into oxygen, all the way down the periodic table. Then it hits iron. Iron will not fuse. Iron absorbs energy instead of releasing it. And in that moment, the engine that held the star up for 10 million years just stops. What happens next takes less than 1 second. The core collapses. We are talking about a ball of matter roughly the size of Earth compressing down to a sphere about 20 kilometers across. In less than 1 second. The density it reaches is so extreme that a single teaspoon of the resulting material would weigh about 4 billion tons. That is not a number you can picture. That is a number that breaks your brain's ability to scale. Now here is where sound enters the story in the most violent way imaginable. As the core collapses, the outer layers of the star come crashing inward at a significant fraction of the speed of light. They slam into that newly formed ultra-dense core and bounce. That bounce is where the supernova explosion comes from. But the bounce does not work the way a rubber ball works. It works through pressure waves. Through sound. Except the medium carrying those waves is not air. It is nuclear matter. Matter so dense that the rules of normal acoustics have completely broken down. In air, sound travels at about 340 meters per second. In water, about 1,400 meters per second. In steel, nearly 6,000 meters per second. In the core of a collapsing star, sound moves at roughly 100 million meters per second. That is about one-third the speed of light. The medium is so incomprehensibly stiff and dense that it transmits pressure faster than anything you have ever interacted with in your entire life. And here is the implication that should genuinely unsettle you. The energy carried by those waves is not just big. It is so concentrated that the wave itself becomes destructive before you could ever perceive it as sound. Your eardrum processes pressure changes. But these waves carry pressure equivalent to 10 to the power of 30 pascals. Normal atmospheric pressure on Earth is about 100,000 pascals. We are talking about a difference of 25 orders of magnitude. Your entire body would not just be destroyed by these waves. It would be converted into plasma before a single nerve signal could travel from your ear to your brain. If this blew your mind, subscribe right now. We cover science that textbooks bury under boring language. Every week. But let us go one level deeper. Because the sound wave story inside a collapsing star has a second chapter. And it is even stranger. Those rebounding pressure waves do not always successfully blow the star apart. Sometimes they stall. The energy gets absorbed by a dense layer of material called the stalled shock. For a fraction of a second, milliseconds, the supernova is actually failing. It is like a gun that almost misfires. And physicists spent decades puzzled by why supernovae actually succeeded in exploding at all. The answer turned out to involve neutrinos. Neutrinos are subatomic particles so weakly interacting that a light year of solid lead would only stop about half of them. They pass through you right now at a rate of about 65 billion per square centimeter per second, and you feel absolutely nothing. But in the core of a collapsing star, the density is so extreme that even neutrinos get trapped. They build up, they deposit energy, and that energy reheats the stalled shock wave and gives it the kick it needs to explode outward. The most antisocial particle in the universe, the particle that ignores virtually all matter, is the reason stars explode. The reason heavy elements exist. The reason you are made of carbon and iron and oxygen instead of just hydrogen and helium. Every atom in your body that is heavier than iron was forged in a supernova shock wave. Those sound waves we talked about, the ones moving at one-third the speed of light, they are the mechanism that scattered those atoms across the galaxy. You are, in the most literal sense possible, the debris of a pressure wave that traveled faster than you can conceptualize. Now think about what that means for how we understand stellar death. We tend to think of explosions as violent endings. But a supernova is the opposite. It is a violent beginning. Every planet, every ocean, every molecule of DNA, every neuron firing in your brain right now, all of it traces back to a shockwave, to a sound wave inside a dying star. And here is the part that keeps astrophysicists up at night. We still cannot perfectly simulate a supernova explosion. Our best supercomputers take weeks to model a few hundred milliseconds of core collapse. The physics is so chaotic, so multi-scale, involving nuclear forces and gravity and neutrino transport simultaneously, that we are still filling in the gaps. The universe ran this calculation in real time. We cannot. There is something almost humbling about that. The most powerful computers humanity has ever built, running for weeks, just to approximate 1 second of what the universe does constantly, in every galaxy, without effort. Sound waves at 1/3 the speed of light. Neutrinos saving a dying star's explosion. Atoms of your body scattered by a shockwave 4 billion years ago. This is not science fiction. This is what is actually happening out there. If you want more science that makes reality feel genuinely stranger than any story humans have invented, subscribe and hit the bell. Next video goes even deeper. You do not want to miss it.